Okay, in this video we will solve this problem right here, and in the description box of this video there are two playlists. One playlist has categorized limit problems and the other playlist has random uncategorized problems. And so let's begin. So first I like to just plug in. So it says a limit as x approaches 0. If I plug in a 0 here, I get 5 times 0, so 0, and 4 times 0 is 0, so I have 0 over 0, which is a red flag that you have to approach this problem differently. Now, because we're working with the absolute value of x, we can split it up because there's two situations with the absolute value. We have regular x and we have negative x. Now, the absolute value of x behaves like x whenever you have x is greater than or equal to 0, and it behaves like negative x whenever you have x is less than 0. I'll show you what I mean by that. So if x is 0, absolute value of 0 is 0, likewise 0 is 0. If x is greater than 0, let's say 1. Absolute value of 1 is 1, 1 is 1. Good, they're the same. Now let's say x is less than 0, so negative 1. The absolute value of negative 1 is 1. Likewise, negative 1 is also 1, so they're the same. So it does depend on the situation. Now we have the limit as x approaches 0, so we have to consider as x approaches 0 to the left and as x approaches 0 to the right. And I'll show what I mean by that. So we're going to split it up. The limit as x approaches 0 to the left for 5. Now it's saying 0 to the left. That means I'm using this piece right here. That means I'm going to be using negative x. So I have negative x divided by 4x. Likewise, I have to do as the limit approaches 0 to the right. So I'm going to get 5x. I'm going to be using this piece right here divided by 4x. Now we can cancel the x and we would get negative 5 over 4. We can cancel the x, we get 5 over 4. Because both limit approaches different number, therefore we say the limit does not exist. And that's all we need to do for this problem.